Here we are asked to solve algebraically these problems below. So this problem here looks like we're talking about a half-life problem. So before I even get started on this, just a reminder about half-life. Half-life deals with exponential functions. Exponential functions, kind of the basic exponential function is this. We have some specifics on half-life though, where if we're dealing with half-life, the y value here represents something specific. So does the a value, the b, and the exponent. It's just a very specific type of exponential function, where in this case, b is going to be 1/2, hence the name half-life. A is the initial amount of the thing that we're talking about. Y is like the final amount. So after it has decayed for a certain amount of time, it's going to be equal to y. Which, again, something to maybe think about is that this a value should always be a bigger number than the y value because this thing is decaying, right? It's not growing. So I start with something, it decays, I end with less of that thing. And then the last thing is the exponent here is just the time over the half-life. So we're going to rewrite this exponential function when we read this situation. So element K has a half-life of 56 days. The sample was originally 1,800 pounds, now only measures 2 pounds. And we're looking for how much time has passed. So when we write this equation here, the y value is how much we end up with, which is 2 pounds. A value is how much we start with, which is 1,800 pounds. The b value is always 1/2 because we're talking about half-life. And then we're looking for the time, and our half-life is 56 days. So setting up the problem is kind of the hardest part, I would say, because now we're just using algebra to solve. So divide both sides by 1,800. That simplifies to 1/900. Equals 1/2 to the power of t over 56. And now I take the log base 1/2 of both sides because that will bring down that t value. So I have log 1/2 of 1/900 equals t over 56. And then my last step would be multiplying both sides by 56. So if I was writing this out as just the equation of what my answer is, it's 56 times log base 1/2 of 1/900. When I plug this into a calculator, I'll use change of base formula so that I can easily use log base 10 as the button. And when I plug this in, I got to figure out what the actual answer is. I do log of 1 divided by 900 divided by log of 1/2 times 56. I'm going to get my answer rounded to the nearest thousandth of 549.572 as my answer.